acids and bases in the physiological system. In the physiological system or in the living system, most of the reactions, they involve the exchange of protons. So they are basically acid-base reactions. Okay, so they are acid-base reactions. We know that the proteins are a major part of our body and they are composed of amino acids. Amino acids further are composed of carboxylic acid groups. So there's the carboxylic acid group and amino group along with the R group. But we are mainly concerned with this amine group and carboxylic acid group. Now, in order to know whether these carboxylic acid group or the amine group, how are they existing? Are they existing as such at a certain pH, or they are existing as carboxylate ion or ammonium ion? We need to know this because that helps in predicting the course of reaction or to understand how the reactions they are taking place. So in this video, we're going to study all about this with certain examples. Now to start with, you know that there is a word which is called neutral solution. What does this mean? A neutral solution means where you have a concentration of H positive or hydronium ion. The concentration of hydronium ion is equal to the concentration of hydroxyl ion. And this is equal to 1 times 10 raised to the power minus 7 moles per liter. This is the concentration. Okay. Now it's difficult to imagine 10 raised to the power minus 7, minus 14 and all. That's a very small value. So that's why we devised this scale which is called pH scale, where pH is equal to negative log of concentration of H positive ion or concentration of negative log of concentration of hydronium ion. Both are same. So if we substitute the value of concentration of hydronium ion, which is 10 raised to the power minus 7, we'll get the pH to be 7. So for neutral solutions, the pH is 7. Okay. So based on that, a scale is devised wherein the pH from 0 to 7 is acidic, from 7 to 14 is basic. So this is neutral. When you go from 7 towards 0, the acid strength increases. Acid strength increases, or you can say the concentration of hydronium ion is increasing when you go. From 7 towards 14, basic strength increases. Okay, or the concentration of hydronium ion is decreasing while going from here to there. Fine. Now we'll use this knowledge now to see how the things work in physiological system. So coming to blood, it's our major body fluid, like which transports the oxygen and do all the functions. So blood is buffered at a pH of to a pH of 7.35 to 7.45. So we'll take the value as 7.3. Okay. So this is called physiological pH. Physiological pH. So whenever I will use the word physiological pH, it implies 7.3. Okay. So I use the word buffered. So buffer is any solution which resists the change in pH by the addition of small amount of acid or base to that solution. Resists the change in pH by addition of small amount of acid or base. Fine. So now in order to calculate the pH of a buffer solution, we use this equation which is called Henderson Hasselbalch equation. Henderson Hasselbalch equation, which is as follows: pH is equal to pKa plus log of concentration of conjugate base divided by concentration of acid. Fine. So pH, you know what is the meaning of pH? It is negative log of concentration of hydronium ion or H positive ion. What is pKa? pKa is equals to negative log of Ka, where Ka means, the meaning of Ka is acid dissociation constant. So if the value of Ka is higher, means that is a strong acid and it would have a smaller pKa. Fine. Conjugate base, you know the meaning of this, and the acid is something which gives H positive ion. Okay, so I can rearrange this to log of conjugate base. For conjugate base, I'm just writing Cb divided by concentration of acid is equals to pH minus pKa. Okay, so this on one side and the pKa goes to the other side. So this is log to the base 10. Okay, so this is log to the base 10. So concentration of conjugate base divided by concentration of acid is 10 raised to the power pH minus pKa, because this was log to the base 10. So from this equation, we can calculate the concentration of, the ratio of concentration of conjugate base to acid at a particular pH. So we can predict whether a particular acid is existing as a conjugate base more at that particular pH, or equal amount of conjugate base and acid, or what is the actual ratio of that. Okay, suppose for a particular acid, say HA is the acid, the pH of that particular solution is equals to the pKa of that acid. Okay, suppose this is one scenario. So in that case, above equation would take this form: acid is equals to 10 raised to the power, since pH and pKa, they both are equal, we are taking it to be equal for a scenario, so it means it is 10 raised to the power 0, which is nothing but 1. What does this mean? It means that when the pH of a solution is equals to the pKa of that acid, then that particular acid is existing 50% as its conjugate base and 50% as its acid. So 1:1 ratio. Fine. I repeat, when the pH of the solution is the same as the pKa of that acid, in that scenario, the ratio of conjugate base to conjugate acid is 1, which means that particular acid is existing 50% as acid and 50% as base. So suppose you have an acid like this, RCOOH, okay, and it dissociates. So plus H positive, I'm just writing it simply like this. H positive ion. Fine. So if the pH of the solution is equals to the pKa of this acid, so it means 50% of the molecules will exist in this form, 50% in this form. Fine. So this is of utmost importance in drug designing and drug action. For example, you might have studied glycolysis or Krebs cycle or something, even if you have not studied. So we'll just take the example of one acid which is found in the physiological system in glycolysis, that is pyruvic acid. Pyruvic acid is alpha keto acid, pyruvic acid. So this is pyruvic acid, it's an alpha keto acid. So when it dissociates, it gives us pyruvate anion plus H positive ion. Okay, plus H positive ion. So plus H positive ion. Now at a particular pH, whether the pyruvic acid is existing as pyruvic acid or as pyruvate or as both, if both, then in what ratio, that we can predict based on our knowledge of Henderson Hasselbalch equation. So for Henderson Hasselbalch equation says that ratio of conjugate base to the concentration of acid is 10 raised to the power pH minus pKa. Okay, so at physiological pH which is 7.3. pKa of pyruvic acid is 2.5. So it's independent of that thing. So at physiological pH, the pH is 7.3, pK is 2.5. So which means that the concentration of conjugate base, which is pyruvate, to concentration of pyruvic acid is equals to 10 raised to the power pH, which is 7.3 minus 2.5. So this will come out to be 7.3 minus 2.5. So this comes out to be pyruvic acid is equals to 10 raised to the power 4.8. And if you calculate this comes out to be close to 23095. What does this mean? It means that for one molecule of pyruvic acid, there are 63,000 molecules which exist as pyruvate, which means that most of the pyruvic acid molecules, they exist in the form of pyruvate at physiological pH. I hope this clarifies the whole thing. So we'll do more examples in the upcoming videos. So stay tuned to my channel and do share your questions or concerns or doubts with me. I will get back to you as soon as possible. Thank you.